Good morning, good afternoon, good evening, depending on where in the world you are. Welcome to this webinar hosted by Sonar. I'm going to be your host for today. I'm Phil Nash, a developer advocate here at Sonar, but really I'm just here to introduce Andreas Weis, who's going to be taking us through MISRA C++ 23 and discovering what is new in this new standard. So I just have a little bit of housekeeping to get through before we do get started. So this is going to be a 40 to 45 minute session. That's including Q&A, which will mostly be at the end, but do feel free to ask questions in the Q&A panel as we go. We may answer some as we go, or we may save them till the end, and some of them will be answered there as well. So please use that Q&A box as part of the Zoom interface for asking your questions. Now, there will be a follow-up email in a few days after this recording. So any of the questions that we didn't get to live, if there are any left over, they'll all be there, plus all the ones that we did get to. So don't feel that you have to take any notes of those. We'll also be posting out a post-webinar survey, so you can tell us what you liked, how we can improve in the future. We always want to improve, and what topics we should be covering with future speakers. So we've got a great speaker today. We want to keep that happening. So let's get to our great speaker today. Andreas is a MISRA C++ working group member. So we have this new set of guidelines. Who better than somebody who actually helped to form those guidelines to be here and talk to us about them. So this is Discover What's New in MISRA C++ 2023. I'm going to stop sharing my screen to let Andreas take over. Andreas.
All right, thank you, Phil. Today I'm going to show you a few of the things that are new in the new MISRA C++ standard, and I'm happy to answer your questions. So as Phil said, please keep them coming. This is more fun if it's interactive. To start out, let's maybe talk a little bit about what is MISRA C++ for those of you who may not have used it before. MISRA C++ is a set of coding guidelines. The aim here is specifically to define a subset of the C++ language that makes it harder to make mistakes. So unlike other guidelines like the C++ core guidelines, for example, the focus here is not necessarily on best practices for coding, like making your code especially pretty or elegant. But the focus here is really to keep you away from the dangerous parts of the language and avoid making mistakes.
That's a really small subset.
Right, yeah, unfortunately. MISRA stands for Motor Industry Software Reliability Association. So this was originally a UK-based organization that was formed from representatives from the automotive industry. The standard, while today it goes a little bit beyond that, it has its roots in the automotive domain, and that is still one of its main uses until today. But the MISRA consortium, as we have it today, actually consists of a variety of experts. So it's an international group now. It's no longer just the UK, and it's also not just automotive backgrounds, but it's functional safety people, cybersecurity people, programming language experts, and also representatives from software tooling, which is quite important because when writing a guideline, you also want to make sure that it's tool checkable in the end. So the first version of MISRA C++ was published in 2008, so it's quite old by now. And now this year, just back in October, the new 2023 version was published, and now since a few weeks, you can buy it either by the PDF of the MISRA homepage, or you can also order a hard copy of Amazon. So a few words about the history of MISRA C++ and where this comes from. So the very first edition of a MISRA standard was targeting the C programming language, and that one was published in 1998. And back then, like C++ was not really used in the embedded world, so there was not really a strong demand for it. But as time went on, like people became more and more interested in using C++ also for these kinds of projects. So finally, in 2008, a variant of the MISRA guidelines for C++ was published. This was based on the C++ 2003 standard, which was the latest C++ standard at that time. And if you know both documents, then you will probably see that there's a lot of overlap between the C standard and the C++ standard here. As time went on, C++ 11 eventually got released, and that changed a lot about how we write code in C++. But MISRA was still stuck in 2008, and that led to a lot of people seeing the need for a more modern set of guidelines that incorporates some of these newer language features. And that culminated in 2017 when the AutoSAR organization, which is a standardization body for automotive software platforms, they published their own set of guidelines targeting C++ 14. And they used as a basis here not just MISRA C++, but also a bunch of other guidelines that have been published in the meantime, such as like high integrity C++, the Joint Strike Fighter guidelines, or the CERT C++, but also the C++ core guidelines, for example. And AutoSAR, since like its core business is not publishing guidelines, right? So they weren't really that interested in carrying this forward. So eventually they approached MISRA, and in 2019 there was an announcement that MISRA would now take over what AutoSAR started, would publish a new set of guidelines that would supersede the AutoSAR C++ 14 guidelines. And that was now the document that was published this year, MISRA C++ 2023, which is targeting C++ 17 as the language standard. And I'm going to show you now like some examples for like how those rules look like and what are some of the changes that we have in the new version.
Before you get into your examples,
Sure.
can I have a question on the history? Because
Yeah.
it was 15 years between the original
Right.
MISRA C++ and the new one, if
Yeah.
you don't count AutoSAR itself. So the question is, what took so long?
Yeah. So like in the beginning, MISRA C++ fell into sort of the same trap that the C++ standardization fell into when in 2008, the feeling was that we are done, right? MISRA C++, it's out there and we don't really need an update. And then when C++ 11 was released and like people slowly realized that yeah, that it might make sense to modernize these guidelines. Now, it took a while to like get everybody back together, reassemble the working group, and actually, yeah, start working on a new revision. So that was the main reason here, right? They just lost momentum after 2008 because yeah, in 2008, obviously there wasn't yet a need for a new revision.
So it's going to be another 15 years before the next one.
Well, that's the good thing now. We did not disband the working group after finishing
Great.
2023, so we keep working. We still meet every week to discuss what to do next. And yeah, the hope is that from now on we can publish a much more regular cadence, and yeah, give you much more frequent updates on those guidelines.
Great. Good to know. Thank you.
Yeah, of course. Then, yeah, let's quickly look at like the anatomy of a rule, like what a typical MISRA rule looks like. So if you open the document, you will see a bunch of rules, and they're all structured in sort of the same way. So you will always have a headline at the beginning of a rule, which gives you a brief summary of what the rule is about. And these headlines, they're probably thing that most developers are familiar with, because also when you are using a checker tool, then usually the warnings that you get from your checker tool, they will use the wording from those headlines. Below the headline, we will give a category for a rule, which is a measure for like how important the rule is, or like how severe the danger that is trying to protect you from. So the most strict category that we have is mandatory. That basically says you must always follow this rule. Like there's no you can't really not follow this rule. This is typically reserved. We only have very few rules with this category, but this is reserved for like really severe cases of like undefined behavior, where it's absolutely clear if you write something like this, then your program is broken and there's no discussions. What is much more common is the other two categories. So we have required, which says like this is really like a potentially dangerous thing, and in almost all cases you should not do this. If you don't want to follow a required rule, you have to deviate on a case-by-case basis and like give a formal justification for why you can't get in trouble because of the violation. And then we have advisory, which is a little bit weaker. Advisory has a little bit lower bar for deviation. So we use it for rules where there might actually be legitimate uses where you might want to deviate from it more regularly. And we want to make it easier for users to not follow this rule. Then the analysis section classifies this rule whether it's decidable or undecidable. So decidable here means that like a rule can always check this reliably. And whether the analysis tool needs to look at only a single translation unit, so like a single CPP file, same as the compiler sees the code, or whether it needs to do system-wide analysis where it needs to look at the entire code base. And of course, we always try to keep the rules single translation unit and decidable, because that means they're relatively cheap to check. And you can get reliable diagnostics. So we put a lot of emphasis on this. Then the next section that we have is what is called the amplification. So this gives you a little bit more detail about like what exactly the rule is trying to prevent. Not all rules have an amplification. For some rules, we felt that it's obvious enough what it is, but in many rules, it's there's like subtle corner cases where we give additional explanations, like what it applies to and what it doesn't. Then one of the most important sections is the rationale, because in the rationale we explain why the thing that we ban is bad. And this is particularly important if you want to deviate from a rule, right? Like if you get a violation and you feel that, oh no, I think the tool is wrong here. I really want to write what I just wrote there. Then the rationale tells you like what is potentially bad about the thing that you wrote. And you now have to argue why you cannot run into these problems that the rationale is afraid of. So if you're writing deviations, you should always look at the rationale and think really hard, like, yeah, the things that are being described, they're the things that the guidelines worry about. Is that actually something that can happen in this situation? And only if you're sure that, no, I actually don't trigger any of those bad things, then it's fine to deviate. And then finally, we also always give a code example to illustrate the rule. Usually this includes like both compliant and non-compliant example cases here. And then I have a bunch of examples for some of the rules that we have now in the new standard. And we can look at some of the changes that we have in the new version.
Sounds great, because so far you've made it sound like a bad thing.
Let's see. So we have several kinds of changes that you will notice compared to the old version. So like one example for what changed is where we modernized an existing rule. So for example, in C++11 we introduced the null putter keyword. And a classic problem in both C and C++ is the confusion between like the integer value 0 and the null pointer constant null. And in MISRA C++ 2008, we had a rule that addressed this. And the goal there was to prevent the usage of the integer constant 0 in the context of pointers. So if you had a function that takes a pointer parameter, and you try to call this with the integer 0, that would be non-compliant. Your tool would give you a warning about this, and you would have to change this to instead use the null macro. Now, of course, in C++11, we introduced null pointer, which is a better alternative to the null macro in all cases. So we updated the rule to now require null putter as the only allowed null pointer constant. So this call, which was compliant in 2008, now in MISRA 2023, is no longer compliant. You actually have to use null pointer. Yeah, and we have a bunch of these rules where like they're still based on a 2008 rule, an existing rule, and we now just slightly modernized them based on what was added to the language in the meantime.
So in MISRA C++ 2023, do you still consider 0 to be non-compliant?
Yes, exactly. That did not change. So it's everything that was non-compliant in 2008 is now also non-compliant. But now, in addition, this using the null macro, which was compliant in 2008, that is now also no longer compliant.
Oh, null and void. Right.
Yeah.
Thank you.
Then we also have a bunch of new rules. These are mostly rules that are concerned with language features that did not exist back in 2008. So one example here is lambdas, which were introduced with C++11. So obviously there's no rules about lambdas in the old MISRA standard. But now, like for example, for 2023, one of the pitfalls that we noticed that happen frequently with lambdas is when writing a lambda expression, you can capture values from the surrounding scope to use in the lambda body, and you can capture this either by value or by reference. And if you're not careful, then this and you capture by reference, then that can lead to like dangling pointer issues. So MISRA C++ 2023 introduced now a rule that advises to use explicit capture lists in cases where the lifetime of the value that you captured could be shorter than the lifetime of the lambda. For example, as we see here, like we capture the logger by reference, and then inside the lambda we call the logger to log some message. But now we pass this lambda to like a set callback function, right? So this function will store the lambda in some place and then invoke it later whenever something needs to be logged. And then if the logger object is no longer live at that point, then that could lead to problems here. However, on the other side, we have this example down here where we do capture by reference the value e that we use in the predicate for the find if down here. But for the find if, we know it's not going to store the lambda, right? It's going to use the lambda to perform the find operation, but it's not going to store it away. Therefore, we say like for those simple cases where it's clear that the lambda is going to be used right then and there, it's okay to use this implicit capture. So you just need to say ampersand. You don't need to name the E. But in these cases up here, where it's likely that the lambda will be stored away and will live longer than this function call, you have to make the capture explicit. So you have to say in the capture list, I'm going to capture the logger by reference. And that is what this rule does. As you can see here, like we could have just said we're going to ban the implicit captures everywhere, but we tried very hard to make sure that the rules don't get in your way. So in cases where there's obviously no real danger, like down here for the find if, we also try to not have the rule get in your way, and that is something that that we were very deliberate about throughout the rules, to be sure that like those cases where there is no danger and that might be frequent, that might occur frequently, yeah, the rules take that into account.
That's good to know.
Then another example in the context of lambdas is that there was this rule in C++11 that you could implicitly capture this pointer by using this implicit capture with the equal sign. And you need to do this if you want to access one of the class members inside the lambda body. However, what is often surprising to people that are not that familiar with lambdas is that even though I'm using equal to capture, which usually means I capture the objects by value, so there's no lifetime issues. In this case, the lambda does not extend the lifetime of the surrounding class. So there is actually a similar problem here as with the reference captures. And the C++ committee even acknowledged that this is a dangerous construct and actually changed the rules of the language. So this implicitly capturing this pointer with this syntax was actually deprecated in C++20. In MISRA C++, we therefore decided to already require this stricter model for C++17. So if you try to use an implicit capture like this, it will be non-compliant. You actually have to explicitly spell out this keyword inside the capture to comply with this rule.
Does that apply to capture by reference as well? Because that will also capture this.
I think, yeah, so you can explicitly capture. So this rule does not forbid explicitly capturing this by reference.
I mean, the implicit capture by reference.
Right, yeah. So that is also not forbidden. So then for the implicit capture by reference, you have to make sure that you don't violate the previous rule, right? So if your lambda is could be stored away, if it's not the simple case like with the find if down here, then you have to be explicit here because of that rule. So these are actually like, yeah. So these are actually two separate rules that both restrict what you can write in the capture list there.
Great. Glad to get some closure on that.
Yeah. Okay, then another category of rules that we have is where we try to simplify existing rules, right? So this is unlike the first category where we were modernizing a rule because of a new language feature that came around. We also had a bunch of rules where we felt that yeah, even though the language has not changed really that much in this area, the idioms surrounding this code might have changed, or where we just had the impression that the existing rules were not working really well and required some modernization. So one prime example here is the restrictions on for loops. So in MISRA C++ 2008, there was an entire section of the document that contained rules about for loops and how they should be structured. So there were in total 6 different rules that together define what the desired form of a for loop is. And if you ever try to read this section, then it was a little bit hard to piece all of that information together because it was scattered around 6 rules, and only once you understood all 6 of them, you had the complete picture in your head what the loop was supposed to look like. So for the new version of MISRA C++, we cleaned that up, and we now only have a single rule, which clearly states what the desired structure of the loop is. So you only have to read the one rule, you only have to look at the examples there, and then you know exactly what it is that that is desired there. And it's a lot easier then to fix violations of this. We also recategorized the rule. So previously, these for loop rules were required, and we now recategorized it to advisory, which makes it easier for you if you have a special case that does not fit this pattern to deviate from the rule. Because I mean, for loops are a pretty fundamental construct, and it was not that uncommon that you violated this rule. And then in the old standard, what people did a lot is they just wrote a while loop instead, so that they wouldn't have to deviate the rule. And that is, of course, not how you should do it. So now we said, okay, let's make it advisory so that people don't have to use this as an escape hatch. Then yeah, try a little bit harder to follow the rule and to play nice.
Perhaps another way to work around having to write for loops is to not use raw loops at all, follow Sean Parent's advice and
Exactly.
use
Yeah,
algorithms.
and
So
we actually even discussed that. So for a while in the working document, we had a rule that just said, don't use loops, right? Just use algorithms. The thing is, that was very controversial during the review. So
right.
we decided to remove that now from the version. So the rationale for the for rule actually mentions this, that you should use algorithms. So it's
Good.
still in there, but we don't actually have a rule that that enforces it at the moment, simply because we couldn't find a good way to have this in a rule so that it wouldn't get in the way all the time, because loops are just so fundamental. So yeah, for the moment, we don't have a rule. We just have it in the rationale. But maybe if we find a good way of specifying it so that it hits the right balance, then you might see it in a future version.
So good. It's aspirational.
Exactly. Yeah. Then the last category of rules that I have here is where we removed outdated rules. One example that I think we're all particularly proud of is that we managed to get rid of the rule that restricted early return. So in MISRA C++ 2008, there was a rule that required that there's only a single exit point at the end of a function. So if you had something like this, where like you checked some condition and then you had a return statement to like return at that point from the function with like an error condition, for example, that was not allowed in MISRA C++ 2008, right? So instead, you had to store that value away and then somehow reach the end of the function where like your one allowed return statement was, and then figure it all out from there, which actually led to code that was not really nice to read. And this is a rule with a long history, right? This is in most of the safety critical coding standards, actually. And there was quite some resistance to not having this rule. So we had long discussions here. We actually traced the entire history of the rule, tried to figure out what the original rationale was. So AutoSAR did a lot of prior work here, but we actually like reiterated the whole discussion again. Eventually, after like careful deliberation, we came to the conclusion that it's not a reasonable rule today, and we decided to remove it. So it's no longer there in 2023.
And I think that the timing of this is perfect, coming towards the end of the year. It's like a Christmas gift. So we could say many happy returns.
Exactly, exactly. That's the spirit.
Yeah. But more seriously, I really like the depth that you, as in the committee, have got into here to go back and do that detective work and see actually why does this, why was this in there in the first place?
Yeah,
Do
yeah,
we really need it? So you're not just carrying craft forward, but everything's been carefully
yeah.
re-evaluated. And I think that really shows for a lot of these rules.
Yeah, yeah, and it's really important also because I mean, like for this rule in particular, what was problematic here is that the ISO standard for functional safety for road vehicles mentions this in particular as one possible guideline to follow for source code. So we had to be very careful there not to contradict what this other standard was saying. So we even had
Mm,
to sync like with this other standardization body that is responsible for the functional safety standard, and also convince them that this is a reasonable thing to do. So it's yeah, we really try to get like broad consensus on these guidelines. So it's not just like a couple of people from MISRA in their little room figuring this stuff out, but this really requires yeah, taking a lot of different perspectives into account.
that's great.
Okay, then short summary for what the new standard looks like. So we have over 170 rules in total, and most of them are completely revised from the ground up. So even the ones that look similar to rules that we had before, we reevaluated all of it. We reviewed the wording again, and yeah, most of the rules actually have significant changes as a result of this. Uh, we took into account modern best practices for C++ development. We had a bunch of experts from the ISO C++ committee that contributed to the discussions here that helped with the working document. And I think it really shows. I think it's yeah, it's a good representation for yeah, what the common idioms are for the language today. Um, as I said in the beginning, we try to form a group of industry experts with very diverse backgrounds, taking all of the different interests into account here. Um, and our goal was really like not just make your code safer and more reliable, but also like not get in your way when we don't have a good reason to, right? So as we saw in the rule for the Lambda, if there are like reasonable subsets where it does not make really sense to apply the rule, we tried very hard to carve an exception out for those. And we hope that this document will now be serve as a foundation for like future versions of guidelines and standards for writing reliable software, um, both in and beyond the automotive industry.
Well, thank you, Andreas. Thank you both for giving this presentation, but also for your work on the committee that made all of this possible. And thanks to the rest of the committee as well, including my colleague, like Jolie, who's actually in the background in this call, answering some of the questions.
Yeah.
He was also on the committee. So you're in good company.
Yeah.
Um, a few more of you as well. Excellent job, I think you've done there. Now,
Thank you.
don't go away because we're going to go over some Q&A. We've had quite a few questions come in
Mhm.
that we're going to get to. But if you can drop your screen share just for a moment, I've
Yes,
got
definitely.
one thing to get to first. There we go. So yeah, before we get to the Q&A, just to mention our next webinar. So if you enjoyed this one, maybe you'll enjoy the next one. It's actually about Java. Maybe that applies to some of you. Clean Code in Java, Story of Monsters, Heroes, and Victories. That's going to be given by Jonathan Villa, one of our developer advocates. It's going to be January the 24th. And it's mostly for the APAC and EMEA regions. So we've got 9 a.m. CET, 4 p.m. SGT. So bear that one in mind. And now let's get to that Q&A. So before I get to the list, there were some questions that were answered asked and then answered on the Q&A panel. So they're gone from the top now. But because we had so many people asking the same question, I think it's worth repeating here, which is, is MISRA C++ 2023 going to cover C++ 20? Because obviously C++ 17 is already 6 years behind 2023.
Yeah.
So what's the story there?
Yeah, exactly. So, I mean, obviously, like this has been a long while in the making, right? So um, at the point when we put the working draft for MISRA C++ to the public review, C++ 23 was not yet released. There were some discussions whether it would already make sense to base it on C++ 20, but the problem there is that these guidelines, like we try not to make them up, right? Like we try to standardize what the consensus is in the community, what the best practices are. And it takes a while to like figure this out, right? In particular for the more complex features. And with C++ 20, we now had the problem that we had a lot of features that were quite complex, but not a lot of implementation experience. Like if you take, for example, modules, still the implementation experience today is very limited, and most people just have never used them, right? So we just did not feel comfortable to say like we have a standard that covers C++ 20 simply because we don't have the experience in the industry to claim that we know about all of the sharp corners for the language. The downside of that is, of course, that if you want to use C++ 20 today and you need to do you need to use a coding standard, that you now have to find an argument why that is okay. But we hope to be able to address that through like smaller documents maybe in the future, so that you don't have to wait for the next revision of the full MISRA C++.
Okay, that's interesting. And that sort of partially preempts the next question, which is now you have sort of brought it more or less up to date with C++, C++ 17 support in MISRA C++ 2023. Are you planning to continue sort of matching the 3-year pace of new C++ standards and be at least only 6 years behind?
Yeah. So that is very much the idea. So we have two things that we have planned now for MISRA. The one is to like have a more frequent cadence for the main document. And the other idea is to have like smaller documents that target specific areas that might not be interesting to everyone who uses MISRA. And the first example that we have here is the guidelines for parallel and heterogeneous computing, which I have been working with together with Michael Wong and Ilya Burilov and a bunch of other people. You can actually find like 2 talks from the 3 of us at CPPCon, where we present those efforts. So the idea here is that like a lot of people that write safety critical software don't care about multi-threading, right? They just keep their stuff single-threaded and they're happy with that. So we don't want to clutter up the main standard with a lot of rules regarding threading. But if you need to use threading, then of course you want some guidelines for this, right? So the idea is that then you just use the main guidelines, which always apply, and then you have like specialized guidelines, for example, for threading. And then if you know you need to write multi-threaded code, then you pull them in as well. And so in that way, you can like sort of put together the ideal set of guidelines for your project.
Right. Okay, that makes a lot of sense. Thank you. Now, talking about what went into the guidelines, because when you're talking about AutoSAR, you said that that was influenced by certain other standards. Somebody brought up the book Embracing Modern C++ Safely. Were those considered as part of this effort?
We didn't look at that book in particular. It was published fairly late in the in the cycle of work here. But in principle, like we take into account all the sources, right? So like we take into account like other safety guidelines. We looked a lot at stuff like the core guidelines, but also at like books that are well established in the community. So we try to find a good mixture there.
Mhm.
Again, what is important to keep in mind here is that MISRA has a specific focus. Like we like our target audience is really people that need to write code, safety critical code, typically like in regulated industries. And there's a specific way that this is done, right? There's
Yeah.
specific areas that they worry about the most. So that is the focus for MISRA, and that is slightly different than the focus that the authors of the Embracing Modern C++ Safely book had. But
Okay.
that does not mean that we don't look at it, right? Like we definitely
Hmm.
take this as an input. We evaluate this. We might just get to the conclusion that, for other audience, we follow a different guideline.
Right. Okay. Thank you. Then there was one question about your last example with the
Mhm.
early returns.
Yeah,
I think sort of questioning maybe what the original rationale was. That
yeah.
want to know maybe it was for debugging, making
Um,
debugging easier, just having to put a breakpoint
yeah. So
on return.
if you trace it all the way back, this is a very old guideline, and
Mm.
this has been around since the days where people were writing a lot of software in assembly.
Mm.
Um, and that's actually where it makes sense, right? So
Yeah.
the original idea was really to encourage structured programming, right? So that you don't have like wild go-tos that like jump all over the place, and like you don't know where you enter the function and where you exit the function, right? So this, like the original rule, it was not just like single exit, it was single entry, single exit, right? So
Yes.
they were also worried about you jumping into the middle of a function.
Mm.
Um, and that's really where it came from, right? And then if you follow like structured programming paradigms, as most people do today, um, like a lot of these problems that people had back in the day with multiple returns, they go away, right? And it's in some cases it's even counterproductive, where if you do want to enforce the single return, you need to reintroduce goto in a couple of places so that you can jump to your exit point without cluttering up the whole code with additional conditions. Um, yeah, it's a rule from a different world. And yeah,
Yeah. Makes sense. Thank you.
yeah,
Um, maybe one or two fun questions I think we have time for.
sure.
What's your favorite improvement between MISRA C++ 2008 and
Mhm.
2023?
Yeah, that's a good question. I really like what we did with the loops. I think that was
Right.
like especially for people that have to use these rules and have to understand the warnings that the tool gives them, and how to fix them. I think like that was a big improvement, and that is really something that people feel every day, simply because it's it's so common in the code.
Right. Thank you. And I think we do have to wrap up, but maybe just the inverse of that. What's your least
Yeah.
favorite rule in
Um,
C++
Everything that
23?
has to do with integer promotion. I just like, not because I think the rules are bad, but just like the integer promotion is so complicated in C++, and it breaks my heart every time that such a fundamental part of the language is associated with such difficult rules.
Right. Makes a lot of sense. Well, I think that's all we have time for. So thanks again for staying for the Q&A. Thanks to everyone else for attending, for asking your questions. As we said before, we'll be sending out the complete answered set in a follow-up email along with a bit of a survey. So thank you again, and
Thank
goodbye.
you.